Back again for another episode of Amazing Transformations. Remember, everything we're doing right now, all of these things are called transformations, and they help us determine if two things are congruent. Transformations, and these are helping us with congruence, seeing if two things are the same size and same shape. Today, what we're focused on is definition of reflection and reflection's basic properties. Kind of like translations. We did the basic properties of translations. It maps a line segment to a line segment, an angle to an angle. It preserves the distance. All those things are important with translations. And now we're going to do the same thing with reflections. So you should know the definition of a reflection, and you should be able to perform reflections across a line using a transparency. So you need your transparency, you need a whiteboard marker. Also, you need to show that reflections share some of the same fundamental properties with translations. Translations and reflections, they're both rigid movements. So they preserve the size and shape of the object that is being moved. Okay? So let's have a look. Well, let's do this. Have your transparency paper and your whiteboard marker and copy this with me. So I'm going to make a copy of this right here. If I can, I'm going to do my best. And let's see how it goes. Hopefully you're doing this with me. Remember, this rectangle isn't really a rectangle. It represents a plane. Surface that goes on and on forever in all directions. But we're going to use it as a rectangle. I'm going to use a thinner line for this line, for line L. Actually, I want it to be a little thicker, so I'm going to change that. Okay, let's see. That's better. And now I have point Q on that line. I have point P over here, and I have point A here. Okay, so go ahead and do that. Make sure you have all of those completed. And now what I want you to do is pick up that paper and flip it. So you're going to flip the transparency. But you want line L to be on line L. So when I flip the paper, this P here is going to end up being on this side. And sorry, I can't use technology to do it. This way, and it looks like that. This point A here is going to be over here, and it's going to look like this. And what's cool about the Q point is still here, but your letter Q might be over on this side. It's probably on that side, right? And your letter in L is the same L, but it's probably looking like that if you drew it. So this is a reflection, is just a flip of the image or the point or the line that you're looking at, and we flip across a line. So I'm flipping across L. And so I want to label my new points, and I'm going to label them correctly. So this should be, this should be P prime. Remember that prime stands for the second one. This is A prime. Let me erase. This would be Q prime, but remember the point's the same. And so there I have all my different points. P, Q, and A flipped across that line. Now, answer these questions. How do the reflected points relate to the original image? Well, how do they relate to you? What happened to point Q when you reflect along the line that Q was on? Well, point Q stayed the same. It stayed the same. Nothing happened because it was on the line that we reflected across. And now let's do a few more. So here we have these different images. And I just want to point out that when we reflect across here, if it's tilting away from the reflected line on this side, the reflected image is going to be tilted away from the line. When you reflect an arrow, if the arrow is facing to the right, the reflected image will be facing to the left. Pretty cool. When we reflect these odd shapes, if we have this T, the reflected image will be the opposite direction, which is pretty cool. So if you reflect an arrow across a vertical line, an up and down line, and the original arrow was facing left, which direction will the reflected arrow be? It should be right. If you reflect an image across a line of reflection, how will the distances of the reflected images be related? It's the same distance to the line of reflection. And last but not least, where can a line of reflection be placed? Anywhere. It doesn't matter. It can be placed anywhere, and you can reflect across it. All right? So I'm going to stop there, and I want you to continue the classwork on your own. Use your transparency.